Good morning everyone, and welcome to part one of today's worked exam answer videos, because I'm going to have a look at two practicals today and post both videos back to back in preparation for, of course, tomorrow's final chemistry A-level exam. You are so close, guys. Keep up the good work. I know some of you will have maths today as well, and it will have been a hell of a week for some of you, but you are so close. Yeah, one big final push. You can 100% do this. But in terms of this video, I'm going to have a look at an RP5 question. RP5 being using distillation in the context of oxidizing an alcohol, or in other questions it could be about reflux. Refluxing an alcohol to a carboxylic acid. Here we're having a look at using distillation to make propanone, a ketone, from propan-2-ol, a secondary alcohol. And this sort of question in terms of apparatus is fairly common for this required practical. I have seen them do a similar thing with refluxing. And what we have to do here is, using the figure that they have provided us with, we have to spot 3 problems with the apparatus setup. And for each of those 3 problems, we need to identify what the problem is, describe the issue that it would cause, and suggest how the problem can be solved. Now, you may be asked to draw a distillation apparatus, you may be asked to draw a reflux apparatus, but in the most recent papers, they have tended to opt for more of a question like this, where they give you something and you have to spot the mistakes. And that's the same with some of the methods that previously you might have had to have written. Nowadays, they might give you a method and you have to spot the mistakes and correct them. And I think that's a higher order skill, to be able to look at something that's already been provided and try and spot what's wrong with it, compared to if you were asked to draw it from scratch on your own. But yeah, let's have a look at this particular example. This is a levelled mark scheme. Now remember, not every question that's out of 6 marks will be a levelled marked answer, but I think it's always worth just bearing that in mind. However, I think in this question it's quite easy to see where the stages are. So we've got 3 problems and we've got 3 things for each problem. So each problem is going to be its own stage. So it feels like this one's quite easy to lay out, but still, anytime you see 6 marks, just have a think about how you're going to present your information so that it kind of flows and is nice and logical and systematic. So we're using an excess of acidified potassium dichromate. The propanone is being removed from the reaction mixture via distillation. And then it says suitable clamps are used to hold all the apparatus firmly in place. So they've told us that so that we don't go, ooh, we haven't clamped anything. We have to assume that all of the clamps are in place. In other questions, I've seen them put, say, in reflux, a clamp on the condenser, but they haven't then clamped where the round bottom flask and the condenser kind of fit together. So sometimes the lack of a clamp is something to look out for, but not in this case. So we've got our round bottom flask. They've told us what's inside of there. So a mixture of propan-2-ol, sulfuric acid and potassium dichromate. The sulfuric acid is the acid that we use to acidify the potassium dichromate, and that is something that has been missing in other questions similar to this. So watch out for that as well. I've got an electric heater because, of course, alcohol are flammable, so better than using a Bunsen burner. So we can't comment on that because that's already sorted. Then we've got our condenser, water in, water out, and then we're collecting the propanone in a test tube that's sat within an ice bath. And the idea of doing this when we're distilling off an aldehyde or a ketone is that the boiling points of those are going to be a little bit lower because they don't have the hydrogen bonding between the molecules that the alcohols will have. Or if we're thinking about primary alcohols, or thinking about, kind of oxidizing to carboxylic acids, the carboxylic acids would also have hydrogen bonding between the molecules, whereas aldehydes and ketones don't. They will have permanent dipole-dipole forces. Now, propanone is going to have a slightly higher boiling point than ethanol, but ethanol has a boiling point of 23 degrees, which is essentially room temperature. So by keeping it in an ice bath, we're helping to keep any of the aldehyde or ketone that's been made as a liquid, and stop it from evaporating and then being lost. So it's to increase yield. So you might be able to spot some things that are immediately wrong with this. And again, a really common one is that they have put the water in and out of the condenser the wrong way round. Now, in terms of the water in and water out, the water in should always go at the bottom and the water out at the top. And that, two reasons. One, if the supply of water got shut off and the water was going in the top and out the bottom, it would all drain out of the condenser as soon as the tap was turned off, and then obviously your condenser wouldn't be efficient anymore. If we put the water in at the bottom and out at the top and you turn the tap off, the water can't drain out under gravity because it'd be coming out of the top, so the condenser jacket would remain full. But we shouldn't really be assuming that someone's going to turn our water supply off. So the other benefit of having the water going in the bottom is that we get more of the condenser jacket being filled, because immediately when the water goes in, it's going to fill this bit here. Whereas if you put the water in at the top, it's going to try and find the shortest route out. So you're going to get less efficient cooling if you put the water in at the top, more efficient cooling if you put the water in at the bottom, and if we've got more efficient cooling, then we're going to get more efficient condensation. So that's what we're going to be looking for us to talk about there in terms of identifying the problem, wrong way round. So describe the issue it would cause, less efficient cooling, so some of the propanone may not condense, so that's a yield issue, and then suggest how the problem can be solved, put the water in and out the other way around. Okay, and I will obviously write this down. Perhaps another issue that is fairly easy to spot is this here. So there's two things wrong with this. First of all, when we are warming this mixture here, anything that does evaporate, the gas is just going to escape straight out of the top of this open neck. Why is it going to choose to go down the internal part of the condenser if it's got a route of escape straight out the top of the flask? So this needs to be closed off in some way, but we also need to say that we need to have a thermometer in there as well, because when we're thinking about distillation, we're only wanting to get the propanone out. When we're refluxing, the idea is everything's getting trapped inside for full oxidation to occur. So we don't need a thermometer with that, because reflux means heating at the boiling point. We'll just continue to heat it for a long period of time to ensure that everything has been oxidized. But here, we're trying to only get out the propanone. We don't want the propan-2-ol to start evaporating, because otherwise we're going to get a mixture of alcohol and ketone in our test tube. So by having a thermometer, and the bulb should only be as low as where the outlet of the condenser is, so we don't need the thermometer coming all the way down here into the flask. But by having a thermometer there, we can just make sure we're keeping the boiling point below that of propan-2-ol. So identifying the problem, big open neck of the flask. The issue that's going to cause is all the propanone vapors are just going to escape. So we can fix the problem by putting a test tube in there and then some sort of glass bung, so that the propanone, once evaporated, will go down the condenser, internal tube, be condensed and can be collected, and the thermometer will help us to monitor the temperature so that we're not boiling the propan-2-ol as well. And then in terms of the third issue, and I think this one is quite sneaky, but like I say, they will do this. It's not always a case of something that they've drawn being wrong. It is sometimes a case of them not drawing something or failing to include something. So inside of the round bottom flask with the propan-2-ol, sulfuric acid and potassium dichromate, we should have anti-bumping granules, and the anti-bumping granules are going to prevent the formation of large bubbles, so we'll get smaller bubbles being formed, which will ensure a smoother boiling process, and they have not put the anti-bumping granules in. So it's not a case of spotting, oh, something that they've labelled is the wrong way round, or there's a big obvious empty a big hole in the top of the apparatus where all the gas is going to escape. It might be something as subtle as there's no anti-bumping granules being added. So without those, we're going to get large bubbles forming, which is a lot more dangerous because the boiling process is not going to be smooth, and then we get like shuddering of the glassware, which is not great. Suggest how the problem can be solved: add the anti-bumping granules. So I will pause the video now. I will write all that out, and then I'll come back and just show you what I've written. Okay. And there we have it. So just to show you how I've laid it out, I've identified each problem separately. And then underneath what the problem is, I have written the issue that would be caused, and then I've suggested how the problem can be solved. So if I was an examiner looking at an answer like this, it would be really easy for me to see sort of everything that the student's written. It's very logically presented, and of course when we're thinking about the levelled mark schemes, the chemistry content is the most important thing, don't get me wrong. That will determine which level we end up in, but within the level, say for a level 3, whether you get 5 or a 6, that all comes down to things like the way you present the information, so like no repetition, no jumping around, no kind of talking about the condenser up here and then coming back to it down here, thinking about the terminology that we're using in our answers. So just try and make it really easy for the examiner to see how you've worked through things, and just give it a little bit of thought before you dive straight into your answer. Okay, but that would be a sort of 6-mark answer in terms of the content and the way it's presented. Hopefully that all makes sense. Any problems, please let me know. Any questions, please do ask. And I hope that final day of revision goes well for tomorrow, and that once you finish the chemistry exam tomorrow, and I know some people will have maybe further maths tomorrow, I hope that you can have the best summer ever. Thank you so much for watching, guys. Sending all the very best of luck to you all. Take care, and I will be back with part 2 in a minute.